Hello, this is the Accelerated Math Beginning Algebra series. Today's lesson will be on objective solve a one variable absolute value equation. We'll get started with a definition and then go through 6 problems that are typical of what you'll see in your accelerated math problems. So let's get started with the very first slide, which is on understanding the definition. So definition of absolute value is a distance to zero, which is always positive. Now absolute value is written with two vertical parallel bars that surround either a number or an expression of some sort. We're going to start this off by looking at the absolute value of 4 and absolute value of -4. What we want to do is we want to see what the distance to 0 is from 4 and what the distance to 0 is from -4. To understand this concept, it helps us to look at the number line. We're going to go ahead and place 4 and -4 on that number line. So what is the distance to 0 from +4? Distance to 0 is 4. We go a total of 4 units to 0 from 4. What is the distance to 0 from -4? It's equal to 4 as well. We have a total of 4 units away from 0. So absolute value of 4 is equal to 4. Absolute value of -4 is equal to a 4. Now in algebra, typically we see expressions like this where it has like the absolute value of x is equal to 3, and we're supposed to figure out what x is actually equal to. Now let's start this off by plotting 0 on the number line, and we're going to go a distance of 3 to the right, and we're going to go a distance of 3 to the left. And if we are at +3 on the number line, we would say that the distance to 0 from 3 is equal to 3. If we were at -3 on the number line, we would say that the distance to 0 from -3 is equal to a 3. So that means that x is equal to both +3 and -3. If we were to plug those values into that x spot, we would have a absolute value of 3, which is +3, and we would have the absolute value of -3, which is equal to a +3. Now, one more thing before we leave this slide. What if we had the absolute value of x is equal to a -3? Well, if that stumps you, it should, because there's no such thing as a negative distance to 0. So on problems such as these, you would have to write no solution, no such thing as a negative distance. So let's get started with the first problem here. Well, these are the problems that we'll do, but let's get started with the very first problem. This problem here, what we're literally trying to find right now are what are the x values that we can plug in such that we'll get a positive and a -9. And in order to figure out those x values, we need to set 5x plus 7, the inside of the absolute value, equal to a +9 and equal to a -9. And then we need to solve for x. So let's tackle this one first on the left. We want to solve for x, and so first thing we want to do is isolate the term that actually has the x. So that means that we're going to do the opposite of add 7, subtract 7 to both sides, and +7 minus 7 will cancel, and we are left with 5x on the left, and we have a 2 on the right. And so from here we need to get that x all by itself, so we divide both sides by 5. Now 5 over 5 cancels, and we have x all by itself on the left equals a 2 over 5. On the right over here, we do the same thing. We want to isolate the term that has the x, and so we want to subtract 7 to both sides, and a +7 minus 7 cancels. We're left with 5x all by itself on the left. On the right we have minus 9 minus 7, which is minus 16. And we are going to get x all by itself here by dividing both sides by a 5. And these 5's cross off, giving us an x all by itself, and we have x equals negative 16 over 5. So we have two solutions here. We have one where we plug in, we get a 9. We have another where we plug in and we get a negative 9. Now let's go ahead and check one of these solutions. We won't do both. We're going to go ahead and check the solution with a negative 16 over 5. Let's plug in x equals negative 16 over 5 and see that we really will end up with a correct solution. So let's plug in, and we have 9 equals the absolute value of 5 times negative 16 over 5 plus 7. And so from here, it's just a matter of our arithmetic skills. The 5 over 5 will cancel, and that gives us the absolute value of minus 16 plus 7. And then we have 9 equals the absolute value of negative 9. And the absolute value of negative 9 is positive 9. So that checks out, and we're feeling pretty good about that answer there. So that's how you do your check. You simply just plug in the x value that you found. Let's go ahead and move on to the second example here. I'm just going to show you guys the setup here. This is exactly like the first problem, and we want to know the x values to plug in to get a plus and a minus 13. So we set a minus 3x minus 17 equal to 13, and then minus 3x minus 17 equal to a minus 13. So we solve for x on both, and those will give us the x values to give us a plus and minus 13. Okay, let's move on to problem 3 here. Now on this one here, we have an equation that doesn't have the absolute value all by itself on the right here. We have absolute value and then a minus 7. And we can't set this up equal to a plus and a minus 3 right off the bat. We need to get the absolute value all by itself before we can apply its rules and properties. So we're going to do the opposite of minusing 7. We're going to add 7 to both sides. And we end up with a 10 equals the absolute value of 10x minus 3. Now that we have the absolute value all by itself on the right, and we can set the inside here equal to a plus 10 and equal to a minus 10. And we solve for x. Now, solving for x is just like the first problem, so I'll let you guys handle that one on your own. I want to show you guys a hypothetical example. Sometimes in our accelerated math problems, we'll have this kind of a situation where, let's say we have a plus 7. And so we would start this off by isolating the absolute value all by itself. We'd subtract 7 to both sides, and we end up with a minus 4 here. Minus 4 equals the absolute value of 10x minus 3. And that's kind of weird. How can we end up getting a distance to 0 that's equal to a negative number? There's no such thing. So on this one here, there's actually no solution. So don't get caught writing the inside equal to a plus and a minus 4. We have absolute value all by itself equal a negative number, so therefore there's no solution. Let's move on to the next set of examples. This one here, we would start this one off by getting the absolute value all by itself by subtracting 4 to both sides. So we subtract 4 to both sides and we end up with the absolute value of negative 3x minus 4 is equal to 5. So after that we set minus 3x minus 4 equal to a plus 5 and minus 3x minus 4 equal to a minus 5, and we solve for x. Let's move on to the last two types of problems here. This one here, once again we want to get the absolute value all by itself. There's a 7 right in front of the absolute value, and so we can't apply the properties yet. We have to get the absolute value all by itself. This says 7 times. The reason why I know it says times is because there's nothing in between the 7 and the absolute value bar, so it says times. We're going to undo it by dividing both sides by 7. Once we divide both sides by 7, we get that absolute value all by itself. We have a minus 2x plus 1. Absolute value of that is equal to 5 over 7. And so from here, we would set minus 2x plus 1 equal to plus 5 over 7, and minus 2x plus 1 equal to minus 5 over 7. And so we would start this off by getting the term that has the x all by itself by subtracting 1 to both sides. And what that would mean is we would have to get a common denominator. Now, we might as well make our lives a little simpler if we can. And so I'm going to get rid of the denominator problem altogether. I'm going to multiply both sides by 7. And what ends up happening, if we multiply both sides by 7, these two 7's cross off here, and we end up with a 5 equals, distribute the 7 here, we have a minus 14 plus 7. And that got rid of the denominator issue. And this equation here in blue is one that's pretty easy to solve. Don't got to deal with the common denominator. And so the equation here on the right, we would do the same thing. We would start off by multiplying both sides by a 7, and that would get rid of our denominator issue, common denominator issue, and so we have minus 5 equal a minus 14x plus 7. And now we got those two blue equations that are pretty easy to solve. Let's go ahead and look at the last problem here. This one here, you might be tempted to say, oh, there's no solution right off the bat, but because there's a negative 6 there, but you can't make any judgments yet until you get the absolute value all by itself, and so you would need to divide both sides by a negative 5 to start off. And what ends up happening here is a 5 will cross off with a 5. Negative 5 over negative 5 crosses, and we have the absolute value of negative 9x minus 8 is equal to 6 over 5. Negative over negative, we have positive. And so now absolute value is not equal to a negative. It's all by itself. And so we can set up negative 9x minus 8 equal to 6 over 5, and negative 9x minus 8 equal to negative 6 over 5. And so from here what we would do is get rid of that denominator issue by multiplying both sides by 5. And what happens is these guys cross off, distribute the 5, and we end up with a minus 45x minus 40 is equal to 6. On the right over here, we would end up with a minus 45x minus 40 equal a negative 6 if we were to multiply both sides by a 5. So that concludes our lesson, and I appreciate you joining me. We will meet again in the next objective. Have a great day, guys. It's been a pleasure educating you. This is Mr. Reinheimer signing off.